Okay, ladies and gentlemen, we're going to have a look at the new version 7 schematic. Version 7 is significantly different from prior versions. It's a lot faster, it uses open source simulator, and here we go. I'm going to do it from ground zero in the hope that I can record the first time I install it. You can change these names here. Martin Valichip will do for now. Now then, we're going to install a bunch of other programs. The schematic now will install a special PDF printer that it can use to convert drawings to PDF. And it will install most of a tool called Inkscape so that it can convert to EMF and SVG files. And these are file formats for the web and for quality documentation. So let's just hit the go button on all those things. Here we go. Doesn't take too long, does it? Okay. Now, when the window comes up, it's going to be a little bigger. I'm not recording the entire screen, so give me a moment just to resize the schematic so that it more fits the screen that we've got. So here we go. Obviously, guys, all of the file formats are the same, meaning this schematic tool will open all the old, oh dear me, will open all the old schematics that you've got. I haven't changed the file format, but I have actually changed the detail of how it compresses the files. Specifically, it doesn't compress the files anymore. In the old days that was necessary, but these days disks have got so much stuff going on that we don't need to worry. It looks, as you can see, very similar to the old schematic. This is the last thing that I was working on. This is a D flip-flop, and we are just going to have a go at simulating it with now the built-in simulator. There are a couple of differences that are somewhat irritating, but we'll get over it. NGSPICE, which is the simulator installed right now, I will install XICE at some point as well, but right now it's running NGSPICE under the hood. And NGSPICE requires all variables to be quoted, even when they're not a mathematical expression. So there are some changes to that. And NGSPICE also saves everything unless you tell it otherwise, meaning that it isn't necessary to say save all, so I've commented that out. And apart from that, things are the same. So let's just hit run. This is going to simulate this D flip-flop. And NGSPICE is now being accessed under the hood, and there it is, it's finished. We're now attempting to plot that Q output variable, and oh, it says there's no data. I've noticed that first time around. There is, of course, it's right there, look, but just apologies, I'll dig into that. I'm just going to change this to prove that change. I'm doing 50 nanoseconds now, as you can see, so we'll run to 50 nanoseconds and then plot, and there it is, to 50 nanoseconds. You can see it's extremely quick. Here is the other output. It's so quick because it's really easy for the schematic to talk to NGSPICE, whereas previously there was a kind of a lot going on under the hood. One of the things which we can do slightly differently is if there is an operating point in NGSPICE, as there is now, then when you move over the wires it will show you the operating point. You don't need to put a permanent flag on it. That is N32, it's at 2.5 volts. That there is the clock, it happens to be at 0 volts. That is the other one, 2.5 volts. So you can quickly poke around and look at the DC state of things. I think it'll be useful. Let me show you those extra features to do with printing. Look, if I hold down Shift on the printer icon here, hold down Shift and print, it's now calling for those tools that it installed, the PDF printer and the Inkscape. And that has resulted in the creation of EMF, SVG and PDF representations of this circuit. Now the significance of that is that if you have a Word document that you are using to document things as you go, you can now just insert those things into as a picture. So I just use the keystrokes then to do insert picture from file, and the schematic has put the EMF file on the clipboard. So I just did Alt-N-P Control-V then to get this menu up, and now we'll stick that picture into Word, and as you can see, there it is. And that picture is a vector picture, meaning that so for example, the typical thing I do is I crop the picture to get rid of the white space that's around it, like that, and let me just crop the bottom as well here, and then bring that up and make it look beautiful. And then if you wish, you can then zoom in. So for instance, on this picture, well, let's just do this for instance. You wouldn't normally do this, of course, but let me just explain to you what I'm mumbling about here. If I zoom, if I crop the picture to this degree here, it is a vector. Control-Z, crop, and the picture to this degree. It is a vector representation in the Word document, and so of course when I ask to resize it, it will resize correctly. Look, it's not dots and things. And this is important if you're making pattern drawings. You can insert them into Visio and so forth. So these vector representations are much more, much more flexible to document, and that is working from just that hold down Shift key. Don't save. What I'm saying is hold down the Shift key there. Okay, well I hope that's helpful. The rest of it is just the same as before. What I'm going to do here is I kind of like the wires to be a little bit thicker. Here's how you change the text size. You've seen that before, I'm sure. If you hold down the Shift key, it changes the size of the drawing kind of thing. You look big fat lines in case you prefer to look at it like that. Here, back to the skinny lines again. I'm holding the Shift key down now, and it's changing the thickness of the line, not the thickness of the text. There's the text getting bigger. Lots of things to play with. Give it a try. I need to add some open source models to it. I found some university models that look absolutely awesome that will go down to 7 nanometers for us, so we can begin to explore really high performance processes. And I'm going to add a process from a team in California that will allow us to do bipolar designs, good old bipolar designs as well. Alright, well that's a first look at the new schematic with the built-in simulator.